Hey YouTube, welcome back to Spark Starter channel. I just wanted to do a video on this quick and easy high voltage power supply. I've used it in a couple different videos I've done, and I'm just going to just open it up, show you what's inside, and talk a little bit about how it works. So all that's inside here is the power cord comes in. One side of the power cord goes to one side of the ignition coil. That also has a wire that comes over and serves as our ground terminal. The other line, hot line of the AC power, comes to just a switch, on and off switch. Then it goes to our dimmer. And then the knit dimmer is hooked to one side of this capacitor. And then the other side of this capacitor is hooked to the other side of this ignition coil. So, super simple. So here are just some different automotive ignition coils I have. Any one of these will work. It says 12 volts on here, but we're pulsing these guys with 120 volts to get our arc for this project, to get our high voltage. A variety of different dimmer switches will work. So as long as they have that triac clipping circuit in them, the dimmer switches will work. I haven't found a dimmer switch that won't. And it works on a variety of different types of coils. You can see there's a bunch of different makes and models, some some of the newer version of ignition coils. This circuit will work with all these. Alright, so this is the schematic overview of our simple high voltage power supply circuit. So we have 120 volts AC coming in. It's going to go to our 17 microfarad capacitor. And this is rated 120 to 240 volts AC, and this is this guy here. Then it's going to go to our auto ignition coil. All right. And positive terminal goes to the top of a primary coil, and the primary coil and the high voltage secondary are grounded together, and that goes to the negative terminal of the coil. And I took one of these guys apart. Now there's iron core that's around this, but this is the primary coil, which is number of turns of thick gauge copper wire, and it goes to this secondary. This is the high voltage secondary, and this is a little, you can see it's oily. So this was inside of these ignition coils. They're surrounded by iron and immersed in like an oil cooling and insulating fluid. And I'm not sure if you can see, but inside this coil, the high voltage, this side would be the high voltage side, and then the other side goes to a metal tab that would ground the other side of the high voltage to the chassis of the coil. So that's the internals of the auto ignition coil, the cylindrical style. Okay, so moving on, then it goes to the dimmer switch we have here, and the magic inside the dimmer switch that makes the high voltage pulse is the triac. So once the AC voltage gets to a certain level, and that's adjustable by the dial on the dimmer switch, the triac will turn on, dump the capacitor energy through the coil, and you'll get a current impulse. Now I added a 1 ohm power resistor here. This is not necessary. You can just wire it right to the ground side of your AC line, but I'm using this as a current sensing resistor so we can see the current pulse that goes through the ignition coil. So first thing we're going to look at is the voltage across the dimmer switch, and we're going to turn it on and see the triac clipping that generates the pulse through the coil, and then we're going to look at the current pulse with our current sensing resistor and a differential probe. Oh, I've measured some values on those ignition coils. So the primary resistance is about 6 ohms and 7.5 millihenries. And the high voltage side should be about 6 kiloohms and 26 henries for the secondary coil. So those are some specs if you don't have measuring equipment and you're trying to define some parameters for a circuit design that integrates these auto ignition coils. All right, so let's get on to the demo. So just a little bit more overview of the circuit. This is my high voltage probe that I've used in other Spark Starter channel videos, so you can check out if you want to learn more about the high voltage probe. But right now I'm just using it to measure the AC from our extension cord. And that's helpful because when we see that clipping, it's good to see how the dimmer switch, the triacs and the dimmer switch are going to clip the sine wave. So we've got a nice clean, our reference sine wave will be the channel 2 blue sine wave. And when we turn that dimmer switch on, you're going to see the triacs clip the trigger on and pass current through the coil, and you're going to see a voltage drop at the peak of the sine wave. So, dimmer switch is on. High voltage arc from the ignition coil. You can see as the dimmer switch triggers on, as the voltage increases, dimmer switch triacs turn on, current impulse, cycle repeats, current impulse, cycle repeats. And I'm going to adjust the dial here, and you're going to see that how the clipping changes. And you get the maximum arc power when that triac turns on near the peak of the sine wave. So the next thing we're going to look at is we're going to use our high voltage differential probe here. We're going to switch over, and now we're going to look at that current impulse. Or I just did a capture, oscilloscope screen capture here, so we can discuss the waveform quietly. And so here we have the AC sine wave reference and the current impulse as measured through the 1 ohm power resistor. So that's what's traveling through the series circuit that we discussed earlier. And according to our probe measurements, we're getting roughly a 20 amp impulse current through that coil. So our our differential probe is on 200X. We're measuring across a 1 ohm resistor, and our oscilloscope is scaled correctly. So we're measuring 10 amps per division on channel 1, and measuring 2 divisions. So we have a 20 amp impulse into our coil. All right, so this is a test I've been wanting to do for a long time, is to finally measure the output of this ignition coil. So I increased the distance on the spark gap. I pulled it a little bit farther apart than it would arc, so I can get the open circuit voltage measurement on this coil. And this terminal is connected to one end of my high voltage probe, and the negative terminal is connected to the other end of my divide by 1000 high voltage probe. And you might have seen that on another video. So if you're curious about how to build this, you can check out my high voltage probe video on SparkStarter channel. And what I found is by taking this, even this divide by 1000 probe, I even hooked directly to the oscilloscope. I still had some clipping. So I ran it through my differential probe on the 200X setting, and I've compensated for 200X on my oscilloscope. So whatever our measurement finally is on our oscilloscope, we're going to multiply it by 1000, and that should indicate roughly the peak output voltage of these ignition coils. So I'm going to turn it on. Let's give it a shot. All right, our ignition coil is running. You can hear some faint arcing, but it's not a constant arc, so we're measuring the open circuit voltage. Our differential probe on 200X, and it's compensated on our oscilloscope. And we're measuring at the peak of our transient. Let's measure the cursors here. 27 volts differential from 0 to the absolute peak of that high voltage transient. So we're looking at an output of 27,000 volts approximately. And this is measured from our differential high voltage probe through our high voltage divider resistor network connected directly across the output of the auto ignition coil. So hope this was helpful, and good luck in your high voltage experiments. There's lots of good things you can do with the auto ignition coil and this simple high voltage circuit. So hope you like and subscribe. Thanks.